The doubling pattern that we've seen in Moore's law that we have tracked for 60 years now, your device doubles every 18 months in its capability, we're now seeing that doubling pattern in a dozen technologies. And this is utterly unique. In the history of mankind, at any given point, maybe one technology was accelerating or another. Never have we had a dozen of these. Drones are doubling every 9 months in their capability. The speed at which we can sequence the human genome is doubling every 5 months. In neuroscience, the resolution at which we can image the brain is doubling every year. And so this is a very unique point in time where we have all of these technologies accelerating. And so the aggregate effect becomes quite incredible. It's very, very hard. Our brains have a very difficult time with this. Cognitively, all of our education, intuition, training about the world teaches us linear extrapolation. You take your past performance, you draw a line, here's where I might be. But on an exponential basis, it's a very different heuristic. If I ask many of you, how many of you have heard of 3D printing 5 years ago, many of you would say yes. If I say 10 years, very few of you would say yes. 15 years ago, almost nobody had heard of 3D printing. But 3D printing is actually 35 years old. It is not new. But when it first came out, say in the early 80s, the price performance, the capability was terrible. You could print out 0.001 widgets per hour. 2 years later, it doubled to 0.002. 2 years later, it doubled again to 0.004. 2 years later, it doubled again to 0.008. And for a long time, it looks like zero, and we ignore it, right? Then it gets to 0.1, 0.2, 0.4, 0.8, 1.6, 3.2. Then we call it a black swan. And so if you don't spot these doubling patterns early, they disrupt you very badly. If you can spot them early, it's the biggest advantage you could possibly have, right? When we apply these to industries, we tend to see three layers occurring. The vast majority of our history is very physical products, right? We extract resources, we ship things around, we assemble raw materials. And for many, many hundreds and thousands of years, all of the value creation, business models, revenue generation came from the sheer physicality of the world, okay? Then we added a new layer, a layer where the products are like the Kindle or the iPhone, where the product is physical, but all the revenue is digitally driven, information-based. And now with the rise of mobile internet, we have entire industries that are totally digital with very little physical manifestation. And of course, the world looked like this primarily with very few up here, and now we're seeing that switch around. Today, industry after industry is moving up this stack. I write in the book that the Tesla is not really a car with computers and sensors in it. It's a computer with wheels, right? And you look at it very differently when you think of it in that perspective. Actually, one of our alumni corrected me and said, you're wrong about that. Remember that the Tesla updates itself every few weeks. So you have to think of it as an app that has wheels. So with all of these technologies doubling in the way that we have, this is unique, by the way. In the history of mankind, one technology or another was accelerating. Now we have a dozen, and that basket is actually growing. We're seeing 4 major dynamics occur as a result of all of this. The first is very obvious. We're digitizing the world very, very rapidly. Our memories are not in our heads anymore, they're in our smartphones. All our relationships are now digital because of social media as opposed to analog. 10 years ago, we had maybe 500 million internet-connected devices in the world. We're up to about 20 billion today. Ericsson thinks we'll be at 50 billion by the end of this decade. But because this doubling pattern is happening every year, we'll go from 50 to 100 to 200 to 400 to 800. And in a few years, we're at 1 trillion. Okay? So think of that one statistic. We're at 20 billion internet-connected devices in the world today, going to 1 trillion in a few years. We think we're 30, 40 years into the information revolution. On this metric, we're at 2%. We're just starting. So most of this disruption is ahead of us rather than behind us, right? Now, we found when you digitize, things become very, very disruptive. And the best framing and analogy we've found to describe this transition is photography. Many of you are not old enough to remember film photography. But you're operating, if you remember it, you're operating from a scarcity model and a physical environment, the chemical image on the film. And you're operating from a scarcity model, right? You can only carry so much film. It costs a few reais to get your prints done. It takes a few days to get your prints back. When you move to digital photography and you move to the information-based environment, three really important things happen. First, marginal cost goes to zero. Right? That's interesting. Now I can take 1,000 photographs. The cost does not change at all. As a result of that, the domain completely explodes. In film photography, I'm very carefully clicking here or clicking there because each click is $1. So I have to be very careful where I take that photograph. I have to make sure it's very well framed. But in a digital environment, we're holding the button down on all of our devices and taking billions of times more photographs because the cost is gone. Right? The third thing that happens as a result of this is very subtle but very important, especially from a business perspective, is you change the problem space. So in a scarcity model, you have all these business models that occur around scarcity. Very expensive cameras to help me take the best picture. Courses on photography where I can teach people how to take the best picture. Or publishing books on composition. And all these business models appear to help people with that scarcity. But you move to the digital world and you have a very single problem. We all have 8 copies of our photographs on 10 devices and you cannot find anything, right? And you've gone from a sourcing problem to a filtering problem. And as I said, this is happening across all of these technologies. I want to give you a couple of ways of thinking about this. This is a 700-year look at the cost of light, going from 1300 to today. It used to be very expensive to light up a building or a room. Then we had candle technology, and that plateaus for a while. Then we find electricity, and boom, the price crashes to near zero. And now we barely notice electricity, right? But the shape of this curve is very interesting, because here's the same shape of the curve in DNA sequencing, right? Expensive, plateaus for a while, crashes to near zero. Here's the same shape of the curve in solar energy. And in technology after technology, the cost is crashing to near zero. And this is, again, something very new. In the history of our world, advanced technologies cost a lot. And only a government lab or a big private corporation could afford to innovate and test new models, try new things, launch new products.